Hey guys. So essentially, I want to use this channel to teach people things that I learn. So I've been delving into machine learning. I'm in the very basics, but nonetheless, I am learning it. So today I want to talk about supervised learning and unsupervised learning. There is another type of learning called reinforcement learning, which I'm very interested in learning. But unfortunately, to learn reinforcement learning, you should have a good understanding of supervised learning and unsupervised learning, as many of the more complicated models are based on or built on the foundational models. It's like how in programming, to do a merge sort, you need to understand how a while loop works. Because if you don't know how a fucking while loop works, that merge sort is going to look shit. So, anyways, so the big difference between supervised learning and unsupervised learning is what your data looks like. In supervised learning, you're lucky enough to have a data set like this, okay? And essentially, it is a pair of x's or inputs that are paired with a pair of x's and y's, where your x's are inputs and your y's are outputs, and the outputs correspond to the inputs. Okay, and these x's, we call them features, and these y's, we call them labels. So these features can, essentially, I like to think of them as vectors, because they can have multiple properties. Okay, so if you've done mathematics or physics or something like that, you'll most definitely know what a vector is. The mathematicians, unfortunately, don't have a great understanding of what a vector is, and the physicists, we like to think we know everything, but in this case, we have a better understanding of what a vector is. But nonetheless, these vectors or these features, they use the superscript. Or the superscript is an easy way of denoting this, or denoting this, sorry. So for instance, xi will have feature 1, and this will be feature 2, and this, property 1, property 2, and property 3. And they all belong to the feature xi. And these properties can be many things, but often these will be dumbed down to numbers, because machine learning at the end of the day is math. It's not, you can't tell it that this is a fucking zebra whale and this is a supersonic wave. It's not gonna, you got to do something that makes sense. But often what you will have to do is you will have to, in order to get this data set, you will have to manually go and input or say what this y is. For instance, if I have a bunch of images of animals, I'm going to have to go and say this is a cat. So this cat picture is going to be my x, but then my y is I'm going to have to say this is a cat. Okay, so for your images, you will have to go and label your data set. So that's why the one drawback of supervised learning, and often this is why people will, outsource stuff to India or whatever it may be, or this is why they have master students to do this kind of stuff. Then unsupervised learning, you have a bunch of data which is not in pair form. Okay, so you don't have x's with corresponding y's. You just have a bunch of data points. And really what you want to do here is find a relationship. And this can be difficult for the boys that are incels, the gents who are not in the gym, but but it can be done. Okay, this is a bit boring though. There isn't much learning in this machine learning of unsupervised learning, but we will get to that at a later point. But for now, we're going to stick to supervised learning because it's a bit sexy, I must say. So the two goals in or supervised learning are generally classification or regression. Okay, and regression is about as boring as it sounds, and classification is about as self-explanatory as it sounds. So classification is essentially you want to put your data into discrete groups, or group it into discrete groups. So for instance, you have all your images of animals and you want to group them into the corresponding animals. So you have, let's say you have a data set of images of cats, dogs, and horses. You want to group your image either into the cat group or the dog group or the horse group. Okay? So now we're going to use an algorithm to do that, or what they like to call a model. Then regression is usually with continuous data. Okay, so discrete is you have, groups which are separated. Continuous is you can have anything on the spectrum. This is kind of where the idea of there being an infinite number of numbers between 0 and 1 comes from. So this would generally look like, this would generally be what your regression kind of looks like. This linear regression is an example of it. And here you are trying to best find the relationship in the data and optimize your model / train your model in such a way that when you give it an X, it will give you the most likely, most probable Y that it should give according to the data you trained it on. So here is just an example of a model. So, what is this machine actually learning? Like, what on God's green one is it learning? And that is it's a very good question. So machine learning is actually more mathematics than it is programming. So here is what they call a model. Sorry, I'm drawing like a dot. But essentially what you will do, this is just an example of a model, is you will quote unquote train your model on this data, where you will input your x's into this function. Okay, this is a function which has parameters w and b. I'm just going to underscore these. Okay, these are parameters. We will get into what hyperparameters are later, but for now these are parameters. So you input your x, okay, and we know what the corresponding y should be because we have pairs of x's and y's. So we're going to use these x's and y's to optimize the w and the b, the parameters, in order to build / train a model. And this building / training a model is just optimizing these parameters to essentially fit this data as best as possible. Once we have done that, we can later then take x's, which we don't have paired to y's, and put them into this function or model, okay, and get a corresponding y. And that's essentially your regression. So if you look here, let's just use this dot. Let's just pretend we didn't know this dot was here. Okay, I'm actually just going to draw a new dot. Okay. So if I have an x value, just pretend this is an x value. Okay, I have an x value. Now, I don't know what the corresponding y should be. So for instance, if I have a house of size, I don't know, 100 meters squared, okay? And that is our x, so 100 squared. That is our value. And what we want is to know the price of the house. So we already trained our model using data which was different house sizes, areas of, or floor area, and the corresponding data points were prices. So now we plug in our x, which is our area squared of the house, and it's going to give us the y point on the line, which is, representing the model here, which is going to be our house price, which, I don't know, let's say, because you are poor and nice, is just $10,000. So that's your machine learning, guys, your supervised and unsupervised learning. We will get more into detail on unsupervised learning later, when I do learn some more, and I want to talk about some supervised learning models, or sorry, not models, algorithms, in future. And I will be trying to upload a video every 2 to 3 days. I hope you follow along, and yeah, I'm also going to do a bit of life advice along the way. I might have to get a new microphone. But boys and girls, I hope you enjoyed this one. I will be back in a while. Thank you. If you have any questions, please send them in the comments. If there's something I missed, please say so. I would love to know that what I did wrong, you know. Really appreciate some feedback. Even though it hurts my feelings, you can tell me I'm shit. It's okay. Thanks, guys.